This final brief lecture will just be looking at multivariate regression output, how we write the code, and how we interpret it. So it won't be a long talk. Down here you see we're continuing on with the same data. We've already made regression 1 well up above where we looked at the impact on student-teacher ratio on test scores. What we're going to do now is we're going to set up actually two separate regressions and we'll look at them each individually. I'm going to call the first one reg_2. It's going to be our OLS again. We're going to say test scores. And this essentially is saying is equal to student-to-teacher ratio plus English learning percentage. We're going to pass in our data set again, school, and we're going to fit it. We're also going to make a reg_3 at the same time. That's going to be equal to the test score, and then student-teacher ratio, this English learning percentage, and the percentage of students on meal assistance. And we're going to fit that as well. So now we're going to have two sets of outputs saved so we can look at them separately here down below and not have to run the regression again. So there we go, we've run it. Let's start here with the output for regression 2. If we look at the output for regression 2, you can see we have an intercept, a student-to-teacher ratio, and an English learning percentage. So what we've done here is we're saying if we control for the percentage of students who are learning English, what is the impact on the student-to-teacher ratio? Or I'm sorry, what is the impact of the student-to-teacher ratio on test scores? Well, if you recall what the coefficient was above, it was a little bit over 2. Now it's only a little bit over 1. We come over here, it is still significant. 0.004 is much smaller than 0.05, so that's fine. But what we can say now is for every increase in the student-to-teacher ratio of one student, test scores go down by 1.1 point. This is a much smaller impact than we originally received when we did not control for any other variables. Whether or not this is a large enough impact to justify hiring another teacher is not up to us to decide. This regression does not tell us that. That's up to the superintendent. But what we can inform the superintendent of based on regression 2 is that there is still a significant impact on test scores from the student-to-teacher ratio. If we go ahead and look at regression 3, we can add one more control. Here we have it. Now what we've done is we've controlled for the percentage of students learning English as well as what we said could give a measurement of outside opportunities or economic class. And that is the percentage of students on meal assistance. So after controlling for the percent of students learning English and the percent of students on meal assistance, the impact of student-to-teacher ratios is still a reduction by about 1 point for every student increase in size. Coming across, we find that yes, it is still statistically significant, but again, the magnitude has gone down even more. However, given all of our control variables and given the question posed by the superintendent, we can say with statistical confidence that the student-to-teacher ratio does have a significant impact on test scores. For every increase of one student in that student-to-teacher ratio, test scores do go down by about 1 point. Now, I'll reiterate, we don't know whether or not that matters to this superintendent. Is the 1 point significant enough or a large enough value to justify hiring more teachers? That is, again, not what we are answering here. We are simply saying that there is a significant relationship between student-to-teacher ratio and test scores.